Hi everyone. Today I'm going to be giving you a little introduction to descriptive statistics, and I'm hoping some of this you will remember from 350. So as we get started here, right now you are working on putting your survey into Qualtrics, and remember you're going to be running that by me before you send that out. I do apologize once again for the incorrect link, but hopefully you didn't get too far. If you have not read those emails, remember again, you will need to delete the first account you opened, deactivate that, delete it, and go back and set up an account again through the new link that I sent. Do apologize for that. One of the differences is normally we would go during our class time to the computer labs and just simply do it there. Of course, now in this situation, I'm having to get you the software and having to have you download it directly to your laptops or desktops at home. And we're going to have one more of those to do. But after talking with ITS, I can be assured I have the correct link. I'm sure there will still be problems, and all I can and hope for is your patience and understanding. So hopefully you have your Qualtrics on your computer and you've got that up and running and you're putting your survey in there. Now, the next program, I've put it in descriptive statistics because we're going to start using it sooner rather than later. So again, this is something you are going to want to download as soon as you can this coming week. So this is the link. I checked with ITS. If you click on it, it takes you into our library, into software installs. And if you scroll down, it's going to have the directions on how to install SPSS right here. Excuse me. So if you click on the instructions for the download, it will take you right to where you need to go and explain how to download SPSS. So yes, you do have to get SPSS. That's how you're going to analyze your data. Otherwise, you won't be able to do anything with it. So the next step will be talking about getting SPSS. I'm going to be sharing a data set with you in SPSS as well this week. And that data set will be one where we can kind of play around with and learn how to use it and how it generates statistical analysis. So next step, after we got the Qualtrics worked out, we're downloading SPSS software. All right, when this module, I'll be putting the video and the PowerPoint here for descriptive statistics, but I want to get us rolling with SPSS and get us starting practicing using that because I think it will help you understand how we're going to interpret our data. One of the things in the textbook too, we're starting now into chapter 14. As you go through chapter 14 and 15 and we start talking about these tests, you're actually going to be seeing pictures of exactly what the data looks like in SPSS. So if you have SPSS, one of your upcoming assignments will be a short activity where I'm going to ask you to analyze some data using SPSS. So keep that in mind, that is up and coming, but for now we'll get back to the topic at hand, which is descriptive statistics. So I think these are fairly easy, but I'm going to go over it, do a little review, and hopefully you'll be like, I got all this. This is 350. So straight out of 350. Remember, descriptive statistics pretty much do one thing, okay? They describe. That's all they can do. They can describe a sample to us. They can describe a population to us. They cannot infer relationships. They cannot tell you if a variable affects another variable in any meaningful way. All they can do is describe. So we have two types of descriptive statistics. We have our measures of central tendency, and then we have our measures, obviously, of dispersion or variability, and I'll talk about those next. But I know you're pretty much familiar with the measures of central tendency. They are the mean, the median, and the mode. And let's talk real quick about what those mean. All measures of central tendency are based off the bell-shaped curve, which you see right here. I put it up there. And it's basically that all things basically fold in toward the mean or the middle. So a normal distribution actually looks just like this graph here. So when I give a test, the majority of the scores should be clustered around this high point or this average or this C range. I know you as students hate hearing that, but that's normal. That is what we call average. So the mean is the average of all the scores. So if you have a population and they put, or a sample, and you ask them their age, you are asking them, you would add up all those ages and divide them by the number and find the mean age, the average age. And you would hopefully reach a normal curve. I think your curves will probably be skewed. Your average age will probably be younger, but that's okay for our purposes, but we're going to be talking about that. It's not the medium. Oopsie. That's pretty funny. It's the median. Where was I? It's the median. Sorry about that. See, I make mistakes, guys. I will fully admit it. All right, so I would like you to know about the mean. Not only is the average, but this is the statistical symbol for it, the X with the line above the top. The median, however, is the halfway point. It's the true halfway point of any given sample or population. So when we look at the curve, well, this curve, because it's a perfect bell-shaped curve, the median or the true halfway point is right there. But if the curve were always skewed upward, we'd want to know where is the true halfway. And what we mean by halfway is where half of the scores fall below and exactly half fall above. So if your mean age for your sample is 26, what is the true halfway point where those are below or above? It's probably going to be very close. It's probably going to be 25, if not 26 as well. The median is often close to the mean, but it's the halfway point. And then we have the mode. And the mode is simply the most frequently occurring score or answer. What age did you actually have the most of? For you and your friends group, what do you think will be the most common age you get? What will, I don't know. I'm still guessing young. I'd say your mode might be 22. That might be the most frequent age reported. That's what we're looking at, the most frequent score. So pretty much what descriptive statistics can do is they give us frequency distributions. And your book starts talking about frequency distributions, and I want to take a minute to show you what we mean by a frequency distribution. So we're actually going to go back to Qualtrics. I pulled up a survey in Qualtrics, and this is one that we'll probably do some analysis on. And what it can show us is the frequency. How many people answered strongly agree? How many people answered disagree? How many people, do you see what's going on here? This is a frequency and a graph and a visual representation of my professor admits mistakes when they are made. I'm hoping I got some strongly agrees on that if you took this survey about me. But 158 people said, yes, my professor admits when they make mistakes. 258 said, I agree. They don't strongly agree, but they agreed. All I can get here, as you're noticing, is a bar graph like frequency of how many people answered it each way. So there was a minimum 1, a maximum of 5. The mean was 4.09. We're going to talk about this standard deviation, the variance, and 485 people answered this question. So my professor tells you the hard truth. Let's see. Wow, very nice. So a lot of people agreed. Their professor's just telling them what it does. How about this one? My professor demonstrates beliefs that are consistent with their actions. Ooh, I'm curious now. Most people agreed. We did have one strongly disagree and disagreed. Remember, this is a survey that SDS students took about professors all over SDSU, not just comm professors. They could be rating a professor they had it over in RWS or writing or bio, anything like that. So it wasn't particular to comm. My professor makes difficult decisions based on high ethics. This is good, but this worries me a little bit. They're basically saying, not so much. I don't really, or maybe that's, I don't really know. So certainly all we're getting here again is frequencies. All I can say about this is the frequency that people answered the question. I can give you the mean, I can find the mode, I can find the median, but that's all I can do. Let's see, my professor listens carefully to different points of view before coming to conclusions. Let's see what students said. Oh, this is good. Most people agreed that their professor was not too quick. Let's see, I actively participate in class discussions. Oh, good God, I'm scared. Yeah, we got a lot of people sitting out there not talking. So this is very fascinating to me. But again, all it can tell me is how people, the frequency or the amount of people and how they answered this question. That's all I get from it. So when you're looking at your data in Qualtrics, all you're going to get is descriptive statistics, frequency type data. We're going to want more than that, and we'll get to that next. But you can see now what I mean by just frequencies. That's exactly what I mean. All right, skewedness and kurtosis. We did talk about this in 350. And remember, we're trying to get a bell-shaped or normal curve. That's what we want. That's the ideal. That's seen as how we want things to fall. However, oftentimes that doesn't happen. So this is one of my favorite parts because I had to do this for 350 and it's pretty fun. I'm going to try and draw. So bear with me. I was not an art major. There's a good reason why, but certainly I will do my best to try to make this happen. Oh my goodness. And see already, that's just not even good. Not even good. Let me see if I can do a little bit better job of this. It's just not that easy, guys. Yeah. Okay. As I'm going to call our bell-shaped curve right there. There it is. Now, as we talked about this, if this is our halfway point, when I give a test, and I like using tests because you all can relate to that, and I say 100 is here, 0 is here, where should the mean fall? Well, it should be at 70%. That's usually what we say is the average. But what happens with most tests? At least tests I've had, what happens if everybody scores high up here? You know, then we say this is skewed, and it's skewed positively in that direction. But what happens if everyone scores below a 70? We would say that is negatively skewed. It's going the wrong direction. We want that perfect bell-shaped curve. Ooh, that one wasn't too bad, where everything falls just like this. This is how. So this is supposed to be 100. So when people complain, only 1 or 2 people got a perfect score. Yeah, that's what's normal. And if this is a 0 down here, you know, again, it should only be a few people because these lines are sitting right on the bottom. The majority should be scoring right in the middle. It should fall out nicely. And in general, when I give tests, I look and see, well, what was the mean, the median, the mode? How did the test fall out, etc. We want to do statistical analysis and see, did we have a normal curve or did we have a skewed curve? So we can have a skewed curve. We also talked about in 350 the notion of kurtosis, and there are 2 types of kurtosis we need to be aware of. The first type of kurtosis we talk about being leptokurtic, and this is a type of kurtosis where boom. If this is your bell-shaped curve, I like to think of the leptokurtic as it just leapt right out at you. So let me try and draw this again. Better. Oh, I'm going to get better at drawing with a mouse someday. Maybe just not today. So my distribution looks like this. Everybody scored a 75%, and then it was like this. And what this means, we say this is bad, this is not normal. How did everybody get the same exact score of 73%? What happened? Because that would not happen by chance. So leptokurtic could just leapt right up, everyone got the same score, or everyone fell in the same place, and that would not happen by chance. So something, I would say, you got a group study guide, everyone studied that like crazy, and most of the answers were wrong, so you all got the same exact score. If you that could be a plausible explanation for why everyone got the same score. Now, the other one we said was platykurtic, and we learned about this one, and I like to think of platykurtic as a plateau, and it's just too flat. Everything is flat. The range runs all the way across the spectrum. And that wouldn't happen either. Remember, a curve isn't supposed to be flat like that. It's supposed to, all the people should fall. Remember, this is the bulk of the people here. And you get fewer and fewer people as you go to the extremes or to the outliers. This is why if everybody got 100 on an exam, it would be a leptokurtic distribution, and it would be really, really weird. That means you got an actual copy of the exam, or maybe the professor left the answers on the exam. Something like that would have to happen, because the majority of the people should always be scoring in the middle. The curve is basically an assimilation of the scores rising and falling. So that's what we're looking at. All right, I hope you remember some of the kurtosis and the skewedness from 350, because it is in the text, and it is talked about in chapter 14. Okay, that's it. Descriptive statistics, they all run around a normal curve. The bulk of the answers should be somewhere in the middle. Even when we were looking at the frequencies, here, look at this, almost like a perfect bell-shaped curve right here. Almost. Because, look, very few people strongly disagreed, only 6, and not a lot agreed, although more. And where were most people on this question? Smack dab in the middle. So if I were going to draw the curve around this, I would have a pretty good bell-shaped curve. It's going to be a little bit skewed positively, because agree and disagree, or agree and strongly agree, are a little bit higher over here. So this is moderately skewed. This almost, again, but positively skewed, because the majority of the answers, we should say, would be here. So these are good. I like that I'm seeing some positive skews here. Now, this one. Let me try this one. See, ooh, that's interesting. I wonder what we got here. Also interesting, we're still positively skewed. Still positively skewed. So I think that's kind of still positively skewed. We're not seeing a whole lot following this is close. If this line, I'm going to be quite honest, had been a little longer than this one, you see where we'd have almost a perfect bell-shaped curve. So those are frequencies. This is the curve, and that's what we're looking for. All right, mean, median, mode. We can only get frequencies. How frequently someone answered a question, or what was the most frequent age, or what was the most frequent type of ethnicity, what was the most frequent income bracket or average income bracket. This is all we can get from descriptive statistics. The other set of descriptive statistics is usually more difficult for students to grasp, but it's measures of variability, or in 350 it was called measures of dispersion. And that's because you're looking at how far scores vary or are dispersed in the curve. So in the first time we're looking where scores clump, what is the average, and do we even have a bell-shaped curve? This one says how far out and in between are the scores on the bell-shaped curve. So the range, you know, is the total scores that occurred. So you want to know what was the very lowest score in the test, what was the highest, what was the full range of scores that was achieved. That's what the range is. Variance. Let's talk about this for a minute, because variance is essentially the concept of how far away you are from the average or from the mean. And this is, I kind of explained it differently in 350 this year. I actually explained it by talking about Brad Pitt. Go figure. I'll explain. Basically said, if you know, average good looking. So you're at the mean, or are you really good looking and you vary a lot from the mean? So if and I don't even know if Brad Pitt's the one, if you are Brad Pitt, are you a 5, or are you out here, you know, far away from the average at a 10? And actually there are some sources that would say that he strikes a 10 or close to a 10 in facial proximity and other attractive features. Go figure. So we want to know, how far do you vary from the mean? People often get excited about this when they have kids and they're like, my child's in the 95th percent growth. You know, basically what that's saying is you're varying from the mean quite far. You can vary from the mean in the other direction as well. And I'm not even going to get into examples there. So variance. How far from the average or the mean do you vary? We came up with the notion of standard deviation to better characterize how far away that is. So when you say, well, how far was my score on the exam from the average? And I say, well, you know what? Only one standard deviation away. This is -1 standard deviation. Your score fell within one standard deviation, which we would say is pretty close to the mean. And this is where you start arguing points. Because if you're close to the average, isn't that basically then just due to chance that you're pretty much already met the average? But if your score is 3 standard deviations away from the mean, 1, 2, 3, you didn't even come close. Didn't even come close to the average. And so standard deviation is something that we have made and implemented to give us a better idea of how far away from the mean we are. So I'll go back. Growing up as a kid, I was in the tall percentile. I'm fairly tall for a female. So I don't think I was 3 standard deviations above the mean, but I'm pretty sure I was in the second bracket, and I was almost always in like 5th, 6th, 7th, 8th grade, the tallest girl in my class. So I probably was a good 2 standard deviations away from the mean. And really what that's saying is you're not average. You're not average in some way. I know you've all been told you're special, but you know what? In statistics, we're all about the average, and then how far do you vary from there? So that's what we're looking at when we talk about range, variance, and standard deviation. So variance, we say, is the sum of squares, and standard deviation is the variance squared. I'm not going to get into the technicality of how they came up with that, but know that standard deviation is the set way we look at variance from the mean. All right, I do not want to go into inferential statistics. I just wanted to get you going on descriptive statistics and frequencies. But let me go ahead now and pull up. This is a blank SPSS editor sheet. And this is where we can actually start analyzing. And you see here they have descriptive statistics and they have frequencies. So I can run those types of graphs for every data set that I have. So I will do this very quickly here since we're in the recording already and show you a 350 data set that I have. This is from when you all took the text message dependency scale. And I've probably got about 200 different responses in here. Here's all my variables. And I can run frequencies on this. And this is where your statistics assignment that's coming up is going to have you work on a data set just like what's in here, and you will have to run the frequencies. So let's go ahead and analyze descriptive statistics frequencies. Now, I have to put in the variables I want. Okay, I want to display the variable names. Now, take a look at this. See how there are no variable names here? That's not good. That's where our code book comes into play, because I don't remember what question 1 measured, or question 2, or question 3. So that's one of the issues we're going to be looking at and using those code books. Let's go ahead and put these questions in. I think the first couple ones are all about your text message use. Now, before I do anything else, remember, I'm going to be walking you through this. I'm going to go ahead and look at what kind of statistics do I want. And look at this. The ones we're talking about are all here. We want the mean. Let's get the median. Let's get the mode. Let's get the standard deviation, the variance, and the range. And I want to know if it's skewed and if there's any kurtosis. Isn't this beautiful? Then I'm going to go ahead and hit continue, and then I'm going to hit OK, and boom, it is done for me. Let's take a look at what just happened here. After sending a text message, I check my mailbox repeatedly. Okay, of n equal 232 people have taken this. The mean is 3.29, the true median 4.0. The most frequently occurring answer was a 4, which is agree. The standard deviation, the variance, it's skewed, and we even have the range. Nobody answered this with a 5. Look at that. This is the table. Again, it's broken down into frequency. 18 people strongly disagreed, 61 somewhat disagreed, neither agree or nor disagree. And most people said they somewhat agree. How about this one? I feel disappointed if I don't get a reply to my message immediately. Most people said somewhat disagree. That's where our highest number was, 82 people. And so I can get frequencies. I can also go up here, analyze descriptive statistics. I can check just descriptives if I want, and put those in again as well. So let me come back up here, and I'll put those same 5 in and show you something a little different that I can do. I can say, okay, what are my options here? I want the minimum, the max, the standard. Let's get the variance and the range as well. Style. I can talk about what style I want this in. Do I want to create bar graphs? Do I want to create scatter plots? What do I want to do with it? Then I can hit OK. And again, look at this. It's going to tell me the range on each question. 4, minimum was 1, maximum was 5, the mean, standard deviation, and the variance. So I'm going to be helping you to start, interpreting all of this stuff, but I want you to begin. Reports are in here. Explore. I'm going to be teaching you all of this so you can kind of get used to what you're looking for in here. Graphs, we can do a chart builder. We can do all kinds of graphs up here, and then we can start using visual representations of our data. So bar graphs, area graphs, pie graphs, scatter plots. So drag a chart and use it as your starting point. If I say simple bar graph and I label those, I can go ahead and start looking at the questions I want to, and starting to say, please take this, and I can do the chart appearance, other options. etc. All right. I don't want to get too far into SPSS, but I think I wanted you to get the idea behind a frequency. It's just bar graphs, and it gives us all of the basic descriptive statistics. So that's it for descriptive statistics today. That's all we're going to cover. I'm going to move into inferential statistics, but what we are going to do is work on survey and Qualtrics, downloading the SPSS software, and working our way through this project. So hopefully descriptive statistics, the normal curve and skewedness, I'm really hoping this was a refresher from 350 and you're all following it so far. And that's it. So I will see you next time on Statistics 101.